Okay, next lesson is find the equation of a tangent line. So we need to recall that from grade 10 we've learned that you could have y equals mx plus b to be your slope-intercept form. So slope, and then this is your y-intercept. And we've also learned slope point or point slope form. And then you would have your rise, x minus x1 equals the run, y minus y1. And this would be where you're inserting a point. Okay, and then rise and run is obviously just the split up way to do slope. Okay, so we also can't forget that a derivative is telling us the slope of a tangent line. Okay, a normal line is a line that's perpendicular to that at that point. So this would be the normal line if that's the tangent line. Okay, so that's the normal line. What do you remember about slopes and perpendicular slopes? So for instance, if this was a slope of 3 over 2, then this would have a slope of negative, and then you would reciprocate it. Okay, so obviously you can see that this is going upward and this is going downward, so positive and negative, and you reciprocate it. Okay, find the equation of a tangent line if y equals 3x squared minus 2x. So the first thing we're going to do is find the derivative of that equation. So again, the rules, so 6x, and then this would be minus 2. So now that's the equation of the slope, but we specifically want to know when x is a value of 2. So the slope is 10. Okay, so in a form of rise over run, it would be 10 over 1, and this is our point. So tangent line would go 10, x minus 2, 1, y minus 8. Okay, and obviously you don't really need that one there. Okay, now write the equation of the normal line. So what is the perpendicular slope? It'll be negative 1 over 10. So the normal line will be negative 1, that's the rise, x minus 2 equals 10, y minus 8. So it still goes through the same point, right? Not changing the point, just changing the slope of the line. Okay, number 2. Find the equations of the tangent and normal line at x equals 3 if y equals this. Okay, so now we're missing also the point as well as the slope. So it doesn't matter what you find first, so let's find the point first. So 3 comma what? So insert a 3. Is what you're doing. Okay, so 3 cubed minus 2 times 3 squared equals 9. So now I know I have the point 3 comma 9. Okay, let's figure out what the slope is going to be. So if I derive this, I get 3x squared minus 4x. So that's the derivative equation. Specifically at x equals 3 though is what I want to know. And now I know that the slope equals 15. That's the rise over, obviously, a run of 1, 15 over 1. Okay, so the tangent is going to be 15 x minus 3, 1 x y, sorry, minus 9. Okay, and then the normal is going to be, what's the perpendicular slope of that? Negative 1 over 15. So negative 1, 15, and everything, the point stuff you're writing the same, you're just changing the slope. Okay, last one. Find the equation of the tangent line when it's parallel to this line. Okay, so first of all, what is the slope of this line? It will be 7 because mx plus b. So the slope of this is 7. Okay, so what is the slope of our line? So I'm going to derive. So the slope of this is 4x minus 5. I want to know when is the slope equal to 7. That's what I'm wanting to know now. When is the slope equal to 7? Okay, because it did tell me when it's parallel to this. Okay, you have to be careful of the wording. It might say perpendicular to this. Okay, so I'm going to move this 5 over, divide by 4, and I get an x value of 3. Find the equation of the tangent line when it's parallel. So now, what do I know? I know the slope is 7, or 7 over 1. I know in my point, I know 3, but that's it. So what am I going to do with the 3? I'm going to input it into the original equation. You just have to be careful with this because sometimes it's confusing that you don't want to insert it into this equation because that's your derivative. Here you want to insert it into this equation because you want the y value, not the y prime. Okay, so I'm going to insert 2 times 3 squared, and I get a final answer of 3. Okay, so 7x minus 3 equals 1, y minus 3 is my final equation for a tangent line.